When you wish to view something that is so far away in the cosmos that you will never get there, what exactly do you do? Well, you launch a telescope in space. In order to let us see more of our cosmos, NASA has done just that by launching the James Webb Space Telescope into the furthest reaches of space. The very edge of the universe is one of the locations that the JWST will be aiming at. The discoveries at the universe's edge promise to be terrifying. Now, what exactly will the first telescope at the cosmic frontier discover? Hello there, and welcome back to the Discover Space channel, where we join you explore the universe and the mysteries that lie within. Be sure to subscribe if you haven't already, and let's get on to the video. People have long been interested in the things around them. However, as our research tools advance, we have broadened the reach of our curiosities to include deep space. Our comprehension of the cosmos has advanced thanks to the creation of the telescope. A number of these telescopes are positioned in the body's orbit, such as the Sun's or the Earth's, from which it peers into space. One notable telescope is the Hubble, which has produced spectacular photographs of the cosmos for many years. However, a new, more potent eye has been placed in space, and this eye will aid in our understanding of what really occurs at the universe's edge. That would be the 10 billion James Webb Space Telescope. This telescope was designed together by NASA, the European Space Agency, and the Canadian Space Agency, but it will be controlled by the Space Telescope Science Institute. The JWST is a massive infrared telescope with a primary mirror that measures roughly 6.5 meters. In late 2021, it was deployed aboard an Ariane 5 rocket. How would we know what exists outside of the known universe? Well, by using things we can assess in our observable reality and the known principles of physics, we can then draw conclusions. For example, we observe the universe is spatially flat on the largest scales. It is 0.25% accurately neither positively nor negatively curved. We can determine the minimum size of the universe that must exist before it begins to collapse in on itself if the laws of physics that govern it are actually accurate. The findings from the Sloan Digital Sky Survey and the Planck satellite provide the best data for our extrapolation. According to the two sources, the observable portion of the universe must be at least 250 times larger than its radius, if the cosmos does indeed curve back in on itself and close. It brings us to the conclusion that, assuming there is no topological weirdness, the unobservable cosmos must have a diameter of at least 23 million light-years. It must have a volume of space more than 15 million times bigger than what we can see. Furthermore, there are compelling grounds that the unobservable world should be much even bigger than that. What astronomical object can humans view at its greatest distance? One thing is that we might never see some objects in the universe. Now, you may ask, why is that? Well, that is because this represents the universe's current cosmic event horizon, which is located approximately 16 billion light-years away from Earth. The GNZ11 galaxy, which is around 32 billion light-years from Earth, is the farthest galaxy ever observed. Mind you, we also factor in the growth of space while calculating this distance. We arrive at the so-called surface of last scattering when we were roughly 46 billion light-years from Earth. Whatever angle you look at it from, this is what you will see. After recombination and photon decoupling, the surface of the most recent scattering resembles a homogeneous sphere of fog, from which the initial photons of the cosmic microwave background radiation emerged. Contrary to its name, it is the place where the first light dispersion occurred, albeit the final one that we can see. Now, you may ask again, is this the actual edge of the universe? Well, it's a yes and a no. Technically, this is the edge of the observable universe, the furthest point in space and the furthest point in time that we can observe. The opaque universe is what lies even further than that. This defines the boundary between what we can see and what we can only imagine. Let's venture even further than the farthest limits of the observable cosmos. What could possibly be there? All this time, we have only peered into what was present at a certain point in space in the distant past. A more inconceivable query would be, what could possibly exist there now, at this very moment? What is known as the particle horizon, or the furthest distance one may look into the past, is located at the edge of the observable universe. Everything we've seen up to this point has been viewed from the vantage point of the Earth at the center and temporarily scaled backward in time. This raises the question of whether the cosmos is indeed limitless. Well, it can be inferred simply from Einstein's theory of relativity that a flat world must be endless. So you may ask, can we then draw the conclusion that the universe has no edge or end? We have not been able to definitively identify whether or not the universe is finite. Thus, the answer that you're looking for is not so simple. It is crucial to realize that the universe's edge doesn't actually exist in the way that you might believe and you might have imagined. You might have imagined that the universe's edge is a location where you can spin around and get a zoomed out perspective of everything, including every galaxy, planet, star, and so on. However, this is probably not the ideal way to approach this topic. At least not according to space, which indicates that even if you were to reach the edge, there would simply just be more universe. And that is it for this video. Confusing, lots of questions. We know, we feel you. That's why, comment down below what you think of this topic and let us know what you want to explore next. We'll see you then.